So grade 11, grade 12, physical science learners, I welcome you back. We are continuing with our redox reaction lesson. So in this one, we are going to look at how do we add water if the redox reaction takes place in acidic medium or in basic medium. If it is taking place in acidic medium, we will add water to either side of the reaction to balance the number of oxygen, and we will also add the hydrogen ion. Same applies to when it is happening in a basic medium. There will be an addition of water and also addition of hydroxide ions or ion. Let's go to this example. Balance the following redox reaction. The redox reaction is given. So our job, in order to balance this redox reaction, our job is to identify the reduction half reaction and the oxidation half reaction. If we are able to do that, it will be easy for us to balance this redox reaction. So I've made things easier for us. You can see that I've made some marks there, the blue color and the red color. So let's look at the blue mark here. CR2 072 minus and CR3 plus. So let's check what had happened, because we have to tell which one is an oxidation half reaction and which one is a reduction half reaction. Let's look at what happened here. As part of reactant, we have our CR here, and as part of product, CR is again there. What happened to this CR? If we know what had happened to the oxidation number of CR when it was a reactant and when it was a product, we will then be able to tell whether reduction occurred or oxidation occurred. So for us to be able to tell, we must know the oxidation number of CR before. Here we can tell that the oxidation number is 3 plus. But what was the oxidation number before? If you go to the part 1 of redox reaction lesson, that's where I was teaching you how to find the oxidation number of an atom in an ionic compound. I've done it for you here, don't worry, I've done it for you. CR2 072 minus. I want to find the oxidation number of CR2. The next step here, we know that it will be CR2O7 multiplied by or equals to 2 minus. Then oxidation number of oxygen is minus 2. We put minus 2, multiply it by 7. Here it will be 2R. Then we solve for, it's not 2R, it's 2CR. Then we solve for CR. You do your maths here. At the end, you find that CR is plus 6. So if you want to refresh your mind, you can go back to part 1 of the redox lesson. That's where full explanation has been done there. But this is how you calculate the oxidation number of Cr. Now we know that the Cr here, the Cr2, its oxidation number is +6 as a reactant. And then as a product, we now have 3+. Let me bring back this number line that I've used in part 2. It was 6. Now, as part of the product is 3. What happened to the oxidation number? It has decreased. And then when the oxidation number decreased, it tells us that the reactant has been reduced. And when the reactant has been reduced, there's a gain of electrons. So this tells us that Cr2 O72 minus and Cr3 plus, this is the reduction half reaction. This is the reduction half reaction. This is our reduction half reaction. Let's look at the one that I've used the red marker here, H2S to S. We can tell that the oxidation number of S there is 0. But what was the oxidation number of S as a reactant? We do the calculations. I've done it for you here. For more information, go to part 2 of the redox reaction lesson. How do we find the oxidation number of S in this compound? H2S equals to 0. That's how we start. The oxidation number of hydrogen is 1. Multiplied by 2, it will be 2 plus S equals to 0. We solve for S equals to -2. So before it was -2, and on the product is now 0. Let's come to this number line here. It was -2 as a reactant, and as a product is 0. Which line here fit or correspond with what I'm talking about here? It was -2, then 0. We are moving up. This is oxidation. We are moving up. From -2 to 0 is oxidation. There's an increase in oxidation number. There is an increase in oxidation number, which means that electrons were lost here. So this is our oxidation half reaction. Oxidation half reaction. Here they are, the reduction half reaction and oxidation half reaction. Now, how do we move forward? If we check this ionic compound, it contains O. And this other one, this compound H2S, it contains H, but we don't have H on the other side here of the product. Same applies to this one for reduction. We don't have oxygen on the side of the product. It means that what I've talked about in these paragraphs must apply. There must be an addition of water here to balance the oxygen, because water contains oxygen. That's why we're adding water here. It will balance this oxygen. And then in the one for oxidation, we'll add H plus to balance hydrogen. This is what I've done here. You can see that there's an addition of water, so that we'll have oxygen on this side and oxygen on the other side. There is also addition of a hydrogen ion, so that we'll have hydrogen on this side and hydrogen on the other side. What do we do when we move to the next step. We must balance our atoms. We must balance our atoms. How many CR here? How many CR on the part of a reactant? 2. Then we'll put 2 on the side of the product to balance CR. How many oxygen on the side of the reactant? 7. So what is it that we must do on the other side to balance these 7 oxygen that are on the side of the reactant? We put 7 here so that we have 7 oxygen on the side of the product. But this half fraction is not balanced. It's not balanced because if you put 7 here, now you have how many hydrogen? You have 14. And on this side, you have none. You have no hydrogen. So, but I'll deal with this part when we come to the next step. Let's first look at the one for the oxidation, which is H2S and S. What do we do here? We put the hydrogen ion to balance this one. And then here we have H2. Here we'll also put 2H plus. You can see it in the next step here that I've put 2H plus as to balance the H2, which is on the side of the reactant. I was talking about the 14 hydrogen, which is on the side of the product. And then we don't have it on the side of the reactant. What do? We add hydrogen ion. In this case, we will add 14H plus, because here we have 14 hydrogen. Even on this side, I must add 14H plus. If you check now, the atoms are balanced in my reduction half reaction and in my oxidation half reaction. So what do we do next? We are going to balance the electrons. Remember, in the previous example, I've said that for the reduction half reaction, addition of electrons is done on the side of the reactant. Addition of electrons is done on the side of reactant. And on the oxidation half reaction, addition of electron is done on the side of the product. We are going to apply the same knowledge here. We're going to apply the same knowledge. You can see that if we check the electrons on the side of the product, check the electrons on the side of the product, how many? 2 times 3 plus is 6 plus, ne? Plus 0 for this one here. 6 plus. To balance this 6 plus, I must do something on the side of the reactant, because this is my reduction half reaction. To balance it, I'm going to add 6 electrons on the side of the reactant. If I add these 6 electrons, now my electrons are balanced. Then we go to the second one, which is our oxidation half reaction. The balancing will be done, or the addition of electrons will be done on the side of the product. S plus 2H plus. This side I have 0. And then here I have 2 plus. To balance this 2 plus, because the addition of electrons must be done on the side of the product, I'm going to add 2A minus here. 2A minus here to balance this 2 plus. Now my electrons are balanced. Or not electrons, the charges are balanced. If you check here, charges are balanced. Even here, charges are balanced. The next step is to balance the electrons. In this half reaction, I have 6, and then in this one, I have 2. What is it that one must do to balance or to get the same electrons? Multiply this one, everything here by 2, you will get 12 here. And multiply everything here by 6, here you will get 12. You multiply by 2, you get 12. You multiply by 6, you get 12. And the results of multiplying everything by 2 and multiplying everything by 6 is what is in this next step. The focus here is to balance the electrons. In the reduction half reaction, 12. In the oxidation half reaction, 12. The next step, what do we do? What falls under the reactants part for reduction and oxidation must be written in the side of reactants, and what falls under the products for the reduction and oxidation must also be written under the side of the or on the side of the products. That's what I've done here. Everything that falls under reactants for oxidation and reduction, I've put them here, and all the products, I put them on the side of the product. The next step, like terms. In this case, I have 12 electrons plus 12 E, and also plus 12E. 12E and 12E. They are positive. If I take this to the side of the reactants, they will cancel. Another like term here, H plus and another H plus. In this side or on the side of the reactant is 28 H plus, and on the side of the product is 12 H plus. I'm taking this 12 H plus to the side of the reactants. It will be 28 minus 12. 28 minus 12. And then I'll be left with 16H plus. So I have to copy everything that is left after adding and subtracting the like terms. You can see that this is what is left on the side of the reactant and on the side of the product. If we check this step here, I have 2 here, I have 16, 6, 4, 14, and 6. One can simplify this. There is a number which can go to all these terms here. That number is 2. If I divide by 2, divide by 2 here, you get Cr2O7, 2 minus. Divide by 2 here, you get 8H plus. Divide by 2 here, you get 3H2S. Divide by 2 here, you get 2Cr3 plus. Divide by 2 here, you get 7H2O. Divide by 2 here, you get 3S. So this is our final answer.